Hello, my name is Robbie Dexter Junior Ukau and I will be presenter 1.
Hi, my name is Amirah Sofia binti Ab Malek.
My name is Siti Nursyuhadah binti Ahmad Shafii as the present.
List of contents of this presentation are introduction, problem statement, objective, significant benefit, scope and limitation, literature review, methodology, result, and conclusion.
We will start with today's presentation with the question, what is cryptography? Cryptography is a technique of protecting data and communication by codes. It helps to transform message to make the ciphertext more challenging to decipher. There are two types of cryptography. The first one is symmetric key, which creates a block cipher with a secret key, and the second type is the asymmetric key, which uses a pair of keys, namely public key and a private key. There are four types of public key or asymmetric key cryptography: RSA, Diffie-Hellman key exchange, also known as DHKE, elliptic curve digital signature algorithm, ECDSA, and finally digital signature algorithm, DSA. For today's presentation, we will focus more on DHKE. As time goes by, cryptography is continuously improving from time to time to harden the accessibility of the message.
However, DHKE is not safe and secure anymore for information sharing between two parties. Based on the article of Umar et al. 2012, the exchange process in DHKE gets defenseless against a particular man-in-the-middle attack. In addition, cyber attack can easily guess what operation involved if a small number is being used. Therefore, the objective for this study is to modify the key generation of DHKE by using radical properties based on scheme of Diffie-Hellman in 1976. Second objective is to validate the successfulness of the modified model by using numerical example.
Next is significant and benefits. This modification that we want to apply could improve the Diffie-Hellman algorithm and increase the confidence of its user. The attackers will not be able to access the message if they want to interrupt. Next, the complexity enhance the security of the information that is being transferred between parties involved against the attacker. This study might give benefits to analysts or researchers if they have a desire to improve the security level by using the DHKE protocol. Then, scope and limitation. Our main focus is key generation of Diffie-Hellman, where we implement the radical properties into the model. We use numerical example to make sure that the complexity that we create in the model satisfy the properties of secure DHKE. We use Microsoft Excel and Python programming language for the calculation. Next, we go to literature review. In this study, we highlight 4 papers. First and second, which are Diffie-Hellman 1976 and Umar and others 2012. These two papers are explained about DHKE algorithm, how they implement for the key generation process. The third paper is El-Gamal on 1985, where this paper is explained about encryption and decryption process for DHKE, since DHKE does not have encrypt and decrypt process. And the last is Jaja on 2012, where this paper is explained about Fermat's little theorem that was applied in decryption.
We will now move on to the methodology phase. Phase 1 is the modification of the Diffie-Hellman 1976 by using radical property. Next, we develop an encryption and decryption. Finally, we validate if the modified version of Diffie-Hellman 1976 is successful. This is the comparison between the original and the modified version. You will notice that the generator for the original is denoted as G, whilst the new version is denoted as J equals to open bracket A to the power of X power root of Y plus B. There is also two changes in the modified version, which is the secret and the public key.
As you can see, we have provided you with an algebraic proof of key exchange. Key exchange is done when Alice and Bob share their secret key, and as they put it on their own public key, so that both parties can get the same result, original key.
We will now move on to the development of encryption and decryption. Say that Ali wants to send a message to Bina. Ali will first need to, number 1, do a letter conversion. Letter conversion means that Ali needs to convert all the letter into different letter by shift cipher with a key K. Next, Ali needs to convert it into number, which is step 2, number conversion. In the number conversion, he needs to convert the message into number that is M double prime. Next, if the message is too long, Ali needs to split it into several parts, which is denoted by MQ. And Q is equals to 1, 2, 3 and so on. And finally, after he split the message into several parts, he then compute Z and ZQ and send the pair of Z and ZQ to Bina. Next is the development of decryption. Bina has received the that is sent by Ali. From the pair Z and ZQ, he needs to compute MQ prime by using Fermat-Little theorem. Next is to combine and convert. In this process, he will combine all the MQ double prime to be M double prime and convert it into letter M prime. Finally, he needs to convert M prime by applying the reverse way of shift cipher of key exchange.
Next, we go for the results, where we implement the numerical examples that consists of 3 major levels. The first one is key generation process, where we will get the same secret key between two parties. The second one is encryption process, where the message that in form of plain text will be converted into ciphertext. And the lastly is decryption process, where the ciphertext will be converted into plain text. Next, we go for key generation process, where we use the model that have been modified. Ali and Lina need to agree to choose 5 numbers, which consist of large prime number and public keys. Ali and Lina decided to choose large prime number that started with 5 and consists of 5 digits number only. So they decided to choose P equals to 58129, A equals to 42, power of 2 equals to 1764, B equals to 23, X equals to 2, and Y will be equals to 4. Before Ali and Bina proceed to generate their keys, they need to check first that the value that they choose will produce the primitive root prime number that they choose. So when they substitute all the value into the formula, it shows and satisfies the answer, which is 65, is a primitive root of 58129. Since Ali and Lina choose the value that produce primitive root of prime number, then they can proceed to generate their keys. Ali choose N equals to 16 and M equals to 16 to be his private key, and Bina choose R equals to 23 and S equals to 41 to be her private key. Both of them will generate their key by using the formula given, which are Ali will get 28376 and Bina will get 31318. Then they will exchange their key, where Ali will give his key to Bina and Bina will give her key to Ali. Then they will compute again for the second time, where at this second time computing, they will get same secret key, which are 42407 that represent as key. At this phase, the first objective was achieved.
For the encryption result, let's say Bina wants to send a message to Ali. First, assign the message as M, then shift forward every letters in message with encryption key of 40. Remember, encryption key must be in between 0 and 20. Then convert the M prime in second step into number. Split the message into 4 M double prime, then M1 double prime, M2 double prime, M3 double prime, and M4 double prime. The sixth step in encryption is compute Z, which is equal to 31318, that is same value to B. And the sixth step also compute Z1, Z2, Z3, Z4 by using the equation of ZQ. Then Bina sent 4 pairs of Z and ZQ to Ali. For the result, Ali has 4 pairs of Z and ZQ that sent from Bina to decrypt into 4 MQ double prime by using Fermat-Little theorem. Then Ali combines all MQ double prime into large number that is M prime. Ali then convert the big number into alphabets, which still not the real message yet. To get the real message of Bina, Ali has to shift 14 letters backward. Therefore, the second objective achieved.
In conclusion, we can say that the modification of Diffie-Hellman key exchange scheme by using radical property is a success. This study proposed that with the improvement of the model, it will function as usual but under particular condition. By creating a new and a complex equation, It means that the security is more secure and it is much harder for hacker to intercept and find the security key. Therefore, data and information are protected.
We have come to an end with the presentation. Once again, from P34M21, discussing about modification of key generation of Diffie-Hellman key exchange by using radical property. We would like to say thank you and have a nice day.